Okay, so from a more broader policy perspective type of panel, we will now dive in to a more technical subject, and that subject will be distribution system planning. Again, as things stand right now, the agency widely views the distribution system platform in part of that platform being comprised of this concept of distribution system planning. And our panel specifically that we'll have before the lunch hour is a utility perspective panel. So we are more than pleased to have with us Tom Kirkpatrick, who's the Vice President, Customer Marketing and Distribution Services from AEP, Kevin Hall, Director, Transmission and Distribution Investments from the AES U.S. Utilities. Tom, I don't want to mispronounce your name, Tom, sorry.
Pryatel.
Pryatel, okay, very good. Tom Pryatel, Director, Energy Delivery Operations Services from FirstEnergy, and Lee Mazzocchi, Senior Vice President, Grid Solutions from Duke Energy. Mr. Kirkpatrick, I believe you have helped organize and put this panel together, so let me turn things over to you. Thank you.
Thank you, Chairman Hawk. What we're going to do today is each of us are going to put forward a kind of an opening statement, if you will, 5, 6, 7 minutes to kind of lay out some fundamental aspects of the distribution planning business at our companies here in Ohio. And then we've constructed a set of questions that get to the issues that the Commission is interested in hearing about. And I'll lead us through that series of questions. There's anywhere from 7 to 10 questions out there that I think will get at the things that are of most interest to the commissioners, and we'll do it in a very open format, very conversational format. And at the end of that, of course, we'll leave plenty of time for all of you to ask us any questions that you have on your mind. So that'll be the structure. We'll start with opening statements, and then we'll go to the Q&A. All right, thank you. So I'm going to follow the order that's kind of in the schedule here. So let me start. So just very quickly, again, I'm Tom Kirkpatrick with AEP, and I represent the distribution planning business, both AEP Ohio and across our system, 11-state system. Quick statement, distribution planning in AEP Ohio is evolving into a more complex function. Drivers for these changes are very many, but centered on a few key issues in our opinion. There's significantly more advanced information about distribution system conditions that have been made possible through new technology. We have more information today at our disposal to use in the planning process than we have ever in the past. These come from advanced metering infrastructure that you heard about in the first session today. It comes from sensors that are embedded in distribution equipment on the line. And it comes from sensors that are placed on the line for the express purpose of providing information about line operation. And these are all timestamps. We've also, as a utility industry, expanded our use of SCADA systems for distribution. SCADA has been very prevalent in the transmission grid for many, many years, but only recently, in the last 8 or 10 years, has it come to the distribution business in a large way. So that expansion of the SCADA systems is providing more time-stamped loading information for distribution transformers, station equipment feeders, and then equipment downstream from there where we have distribution SCADA installed. The key item for that is that in the past, many times we got loading information from indicating ammeters and demand meters that would just basically peg what your peak load is, but you wouldn't really know what time that was. And you'd also have a difficult time constructing, the loads and whether they're coincident with each other or not. With SCADA, we now have that all time stamped, and we can actually construct the total load at any time of day as we go about our distribution planning function. There's no question that customer programs have impacted load growth patterns and will continue to do so in the future. These programs such as energy efficiency, demand management, all have an impact on the loads that we see and when we see those loads. Electrification efforts, EV charging for example, have the potential to impact the load in a significant way, in ways we've not seen before. We also see that as being coming clumps of load here and there. EVs, we believe, will be clustered loads based upon demographics. Other loads that you might see through electrification in the commercial industrial sector will cause increases, significant increases in many cases in the loads that we'll see there. And finally, the advent of new distributed energy resources, the DERs that we're seeing deployed by customers on our system, will all have a significant impact on how we do planning into the future. These elements result in greater complexity in predicting future loads. Challenges with multiple base case modeling and understanding of how variable resources will impact system conditions and in different times of the day throughout the load periods need to be studied. AEP has adopted advanced planning tools made available through innovation by our technology partners and through the work of EPRI. So we are advancing our technology capability and being able to understand and draw in all this information and use it in a complete planning model. We've adopted these tool sets at AEP and continue to support their continued development through EPRI and other sources. The distribution grid is complex, and it will continue to become more so as technology is deployed on the distribution grid and as customer systems proliferate. These include DER growth, new load profiles driven by adoption of EVs, and their related charging requirements. AEP Ohio is working to ensure that these technologies and enhancements can coexist in a secure, reliable, and resilient distribution grid. To that point, we believe a number of things. We believe the EDUs are responsible for the reliability and resilience of the distribution grid that benefits all customers at all times. We believe that the EDU is uniquely positioned and uniquely qualified to execute the short and long-term planning of the distribution grid. We believe that coordination with transmission planning to understand the impact of the distribution loads and changing loads and other advanced systems on the transmission grid is more important than ever has been before. DERs and EEDR programs play a key role in the grid of the future. There's no question about that. And we must use all of these resources to meet our reliability and resiliency obligations. And finally, we believe it's the role of the EDU to balance all customer needs and ensure customer value is delivered to all customers as a core requirement of the planning function in a way that does not financially or operationally disadvantage any customer segment. So that's our opening statement. Thank you.
Thank you, Kevin.
Mr. Chairman, Commissioners, and staff, thank you for including us in today's lineup. As mentioned, I'm Kevin Hall, Director of Transmission and Distribution Investments for the AES U.S. Utilities, which includes Dayton Power and Light. We are pleased to get the opportunity to present our thoughts around distribution system planning in the context of grid modernization. At DP&L, we've spent quite a bit of time preparing our comments from a customer-focused, statewide, and practical perspective. Customer expectations and needs, along with today's quickly evolving technologies, are advancing the electric industry at an unprecedented pace. DP&L has plans ready to meet those needs and advance the grid through the deployment of sustainable technologies and solutions. We believe the end result will be a strong and vibrant economy in Ohio, the creation of a strong job market, while at the same time realizing a more reliable and resilient electric grid. As we shared with you last March and July, the mission at DP&L and its parent AES is improving lives by providing safe, reliable, and sustainable energy solutions in the communities we serve. These guiding principles are at the core of each one of our business decisions. A set of timely and meaningful actions resulting from this power-forward forum can promote and help us achieve our mission. While we believe our customer satisfaction levels and reliability performance are amongst the top in the industry, we know we cannot rest on our laurels. We see the trends where customer expectations are evolving and will continue to evolve. This will require utilities to ensure that they are evolving their transmission and distribution systems, customer service capabilities, and supporting processes and systems to meet those changing customer demands. Additionally, the recent rise in physical and cyber attacks on our nation's critical infrastructure is necessitating additional investments in the grid. As part of today's presentation, I'd like to introduce a graphical roadmap for grid modernization. To establish a consistent and meaningful dialogue, DP&L has developed and socialized with our fellow EDUs a framework that we call the building blocks of grid modernization, as can be seen on the screen. These building blocks become our guideposts in achieving the two pillars outlined in Power Forward: technological and regulatory innovation and an enhanced customer experience. As we modernize the grid and as other innovative energy and grid solutions reach the market, the planning and operation of the distribution system will become even more important. The building blocks we're outlining today support the concept that the distribution system truly becomes the nerve center for reliable and resilient electric service for all of DP&L's customers. As noted on our graphic, the foundation for the grid of the future is an enabling infrastructure, and secondly, enabling technologies. Enabling infrastructure ensures that the core components of the distribution system, the poles, wires, and associated equipment we are already familiar with today, are ready and able to realize the opportunities of the future. The second step towards the grid of the future is deployment of technologies that are now becoming core to how a utility plans and operates its distribution system. Deployment of self-healing grid devices and the associated applications allows the utility to improve its overall system reliability by reducing the number of outages and outage duration. Smart meters, along with the associated technology investments, help in providing a better view into the distribution system and how it is operating in real time, from the substations to the end customers. Smart meters will enable the collection of detailed usage information upon which customer-facing applications will be based, such as advanced rate options and portals that can provide cost and usage information to the customers. These technologies are available and in use today. As some of you witnessed at our sister utility, Indianapolis Power and Light, we have deployed distribution automation and smart meters in a way that lets us know a customer is out before they even report their outage. We can more efficiently dispatch crews to outage locations, and we are reducing the overall impact of an outage to customers in both frequency and duration. And we have automated processes that can turn a customer's power back on after payment in a matter of minutes. Without these key enablers and supporting systems and processes, the utility will neither have the capabilities to support new customer applications nor the ability to add resources on the grid that support electrification and distributed energy resources such as renewables, as illustrated in the third category. These applications highlighted in the third category can and are being done today on a limited basis. It is in these areas where the benefits to customers and society in general can really grow. The fourth category highlights those innovations that are yet to come or be developed on a large scale. We view this last step as market transformation. The technologies and applications such as microgrids and community solar have proven to deliver strong customer benefits in many parts of the nation. Thoughtful deployment through the first three building block categories will provide DP&L the flexibility and adaptability to take on much of what will come about as the market transforms. Joe Bentley will be sharing more on this subject on Thursday. In many ways, we are already seeing the distribution system transform from its one-way concept of delivering energy from centralized resources to its end users to a multi-use, multi-directional electron interstate highway. To that end, the planning, construction, and operation of the distribution system becomes more important as technology is deployed and the uses of the grid evolve. The utility will require systems that can process more data from devices and conduct complex analytics to proactively plan for and manage real-time the variety of devices and applications now being deployed and yet to be envisioned for the grid. Examples of these complexities include load forecasting and planning for impacts of distributed energy resources and changes in load at the substation and feeder levels, having SCADA and advanced distribution management systems that can use real-time and historical data from thousands of sensors and field devices to understand the actual operation of and predict the behavior of the distribution system, and the analysis and recommendation of operating and switching schemes in anticipation of problems or at the onset of an actual outage or loading problem. It's the first two categories of our graphic, enabling infrastructure and enabling technologies, that DP&L desires to power forward with in the immediate future. These are the areas that DP&L is now at the beginning stages of and desires to make significant strides. In summary, the time is now to invest in modernizing our grid, meeting evolving customer expectation, growing Ohio's economy through creation of higher technology jobs, and strengthening our nation's critical infrastructure cannot wait. Thank you.
Thank you, Kevin. Tom?
Okay, good morning, commissioners, chairman, and staff. My name is Tom Pryatel, and I am the corporate director of operations for FirstEnergy. And in my role, I support our operating companies, including our 3 Ohio utilities, Toledo Edison, Ohio Edison, and the Cleveland Electric Illuminating Company. And we certainly appreciate the opportunity to participate this morning. Distribution planning, the primary goal of distribution planning is the safety and reliability of our distribution system. It also includes forecasting and managing the loading on our system and the associated load growth on our system to then predict and anticipate and solve loading problems before they occur. So we don't want to result in condition or conductor overloads or equipment overloads that result in outages to customers. We also want to ensure that we maintain proper steady state voltage that we deliver to our customers as well, which is also very important for them as they live their lives. We also recognize that the role of distribution planning is going to change and become more complex as we get into deployment of smart grid technologies and the increasing penetration of distributed energy resources on our distribution system. But before we can even begin to consider smart grid and increasing penetration of distributed energy resources, we also want to state up the importance of modernizing the grid. We appreciate what Kevin displayed on the Power Forward building blocks and the importance of the first block in an enabling infrastructure. And FirstEnergy also shares that view and the importance of establishing a solid distribution infrastructure in place, in which then you could then layer on smart grid technologies that benefit the customers, and also the importance of layering on a secure and reliable communication system, which will then communicate with all the various devices out in the field that bring back data that helps us support and manage and operate the system. The type of infrastructure we're talking about is the importance of just the poles, the wires, the equipment, the flexibility of the system too, along with that secure communication network. And then back in the substation, the importance of installing advanced reclosers and SCADA system that result in reliability improvements and improving the resiliency of our distribution system and give visibility and situational awareness to our operators as they safely and reliably operate that system. At the same time, as we transition into the grid of the future, the importance of an ADMS system becomes essential, again, to help the operations in managing a safe, reliable system. As the penetration of distributed energy resources begins to occur, we was stated earlier that the distribution system has been designed and operated as a radial system, meaning that power flows in one direction. And in order for the grid to operate, there's a certain balancing that occurs to maintain proper steady state voltage for customers, and also to ensure that all of our protective devices in the field operate properly and operate when they're supposed to at the parameters that they're designed to in terms of reacting to a short circuit or fault on the system. Well, as you begin to increase levels of distributed energy resources, you start injecting current flow, which is opposing the normal flow of power on the system, which could then upset that balance of voltage and potentially could upset that balance of short circuit coordination, in which there are engineering solutions to those problems, but they can also be costly as well. At the same time, companies like FirstEnergy recognize that there's potential benefits to deployment of distributed energy resources on our system. Benefits that could be used to reduce system peak or regulate voltage and improve power quality and even provide some frequency regulation. We recognize also that the utilities are in the best position to optimally site where those resources are located on a system to have less of an impact on the system in terms of the power quality or in terms of the impact on protection, which is very important and essential to maintain. Utilities are also in the best position also to gain benefits in the deployment of multiple technologies and all the synergies associated with implementation of storage systems or microgrids, and in the common platform being utilized and the common systems that the utilities operate can really enhance the benefits that those technologies can provide to our customers. It's also important to keep in mind just the value that the grid provides to the smart grid technologies and the grid of the future, and being able to provide resilient system and being able to provide the backup capacity needed as distributed energy resources are deployed, and then also to be able to provide the short circuit ampacity required to start electrical equipment like motors and compressors that require an inrush that the grid can provide to enhance the operations of distributed energy resources in the smart grid. Finally, having a well-planned distribution system is critical for electric utilities to continue to provide a safe and reliable distribution system for all our customers. Thank you.
Tom, thank you. Lee?
Well, thank you again, and good morning. I'm Lee Mazzocchi. I'm Senior Vice President of Grid Solutions from Duke Energy, and really grateful to be a part of this discussion about innovative regulation and forward-thinking policies, and to talk about really distribution planning, but in the context of how we modernize not just the grid, but the entire energy system for the benefit of our customers. Now, at Duke Energy, we're building a smarter energy future. And while when we talk about modernizing the grid, we often emphasize equipment and technology, it's more important for us to really begin with what these things do for our customers, today as well as in the future. And likewise, how our distribution planning methods and tools will have to adapt to build that grid of the future and comprehensive energy system. So when we talk about planning as well as the investments that we make, we've established guiding principles for our strategy at Duke Energy to ensure that our investments provide value for our customers. Early in our planning, we call them the North Stars of our grid investments, to make sure that investments in the grid are number one, customer enabling, giving our customers more convenience or choice or control or flexibility in their energy usage, to include allowing customers to play a different role in their energy experience, maybe in progressive energy management or owning their own distributed generation like solar on the rooftop and integrating those seamlessly into the grid. Our investments likewise have got to improve reliability and make our grid smarter and more automated for our customers, both reducing interruptions as well as improving the grid's ability through automation and limited human interaction to anticipate, mitigate failures, and reconfigure the grid in a way that reduces disruptions to our customers' lives. This will increase safety for our employees, and customers will see fewer and fewer interruptions, and economies for the local communities that we see will be strengthened. Sustainability is another outcome of grid investments. Reducing waste, certainly improving safety, increasing the amount of renewables and clean energy connected to the grid, and creating jobs in the communities that we serve. Now, we at Duke Energy have already implemented a number of changes and improvements to our delivery system to yield benefits for our customers. We're enhancing our system to accommodate different sources and supply options while at the same time improving reliability. And we'll have the technology necessary to continually enrich our customers' experience via interactive channels. And likewise, we value and understand the importance of fair distribution of cost for our customers. This is good news for the customers, as well as for the local communities and the economies that they enjoy. The grid of the future will have new capabilities. It'll be capable of doing much more than it did in the past. That includes increased cybersecurity, certainly better and stronger reliability, as well as the ability to engage other forms of distributed resources, supply side and demand side. The grid will also have much higher levels of performance, primarily reduced outages, more automatic restoration features, and the importance or the ability for customers to have a better overall experience. Now, we've been serving our customers for more than 130 years. And over that history, we've adapted to the changes in regulatory environment as well as other external changes. But just as important, we've adapted to our changes in customer expectations. And our strategic plan is built around transforming our customers' experience. We have the vision, we have the tools, and the determination to produce the greatest value solution for our customers. We want to be more than just a wires company, and we have the expertise and commitment to be our customers' energy provider. We're committed to meeting our customers' expectations. We want to empower our customers with regard to their energy usage and overall energy experience. We want to give them control and ability to make informed decisions regarding the products and services and how those products and services can improve their lives. And we will continue to hear from our customers every hour to be here for our customers every hour of every day. And our customers deserve the opportunity to make well-informed decisions, and they must be free to select from the entity of their choosing those products and services most relevant to them that create the greatest value. And we can't empower our customers to make these decisions if we establish boundaries that function to exclude willing participants, our Ohio electric utilities. So flexibility is needed, both on the systems design side as well as in the policy. We're all familiar with Ohio's rate-making process and the statutes pursuant to which it's implemented. This process has served us well, but as we move to the future, we must not only consider but implement changes to allow the utility to continue to innovate our industry and to meet our customers' ever-changing expectations. A tempered but nimble approach is needed. Otherwise, modernization will grow stagnant. So I'm excited to be here today with this distinguished panel to share our vision and our commitment to modernizing the grid. And I really appreciate the continued support and partnership with the Public Utilities Commission of Ohio, working towards solutions that protect the health of the utility while allowing us to incorporate technology advancements to timely adapt to the customer's ever-evolving expectations. Thank you.
Lee, thank you very much. Tom?
Good, thank you. Thanks, Lee. So what we'd like to do now is we'd like to take a little bit deeper dive into some of these subject areas, give you an understanding, a deeper understanding of some of the details behind the things we talked about in the opening statements. We're going to step through kind of the current role of the distribution system and then what we see change coming, how we see that coming, and then kind of close up with what does that mean for the future, how does it change what we do and how we do it, and finally what are some of the risks and issues that we need to deal with along the way. So let's start with, I'm going to start with Kevin here and talk first about the kind of the current role of the distribution utility and give an overview of how Dayton Power and Light performs their distribution system planning process at a high level to kind of get level set everybody on what that means. And we'll take turns after that to the others. Go ahead.
Okay, great, Tom. So we believe that the electric distribution utilities are responsible for planning, building, and operating a distribution system that can provide each customer with the electric service they're going to need when they need it, including having appropriate single-phase versus three-phase service, desired voltage levels, whether it be primary voltage service, secondary voltage service. And we all do this today via our, do it consistently with the tariffs that are on file, with the PUCO, and those provide for the charges, rates, and other requirements of both the utility and the customer. Up until recently, these functions have been done in a manner where we build our distribution system that takes those more centralized generation resources and transports them across the transmission system and pushes them one way to our customers. Certainly, as we're seeing the industry evolve, that is changing with more different resources being located across the system. Looking at our load at an aggregate system-wide level certainly is important, but not necessarily as important as it used to be. We've seen relatively overall flat growth on our system. However, we're starting to look at specific areas on our system where we're seeing load growth, load change, and we're turning our focus and analyzing our system in those more localized areas. We've got to ensure reliability and resiliency as the usage of our on and of our system changes. And we've got to really get a good handle on how to incorporate more of the localized distributed energy resources such as solar, other distributed generation, battery storage, maybe even some combined heat and power applications. So I guess in summary, we're quickly being pushed from what used to be very simple processes and tools towards using more complex tools to support both the planning and the operation of the system, including complex load flow analysis and system protection designs.
Okay. Thanks, Kevin. Tom?
Okay, for FirstEnergy, the distribution planning process, it begins with a load forecast. And most of our circuits in Ohio are summer peaking loads. And so we start with the raw summer peak load, and then we kind of take a look at it and determine if it was impacted by any system contingencies where load may have been transferred off or load may have been transferred onto it, to then make a correction and come up with that raw summer peak load if it is a summer peaking circuit. And then we also do a weather normalization as well. We know that weather, how hot the summer is, can also have a big impact on the amount of load. So when we do our distribution planning, we plan to an 80-20 summer, meaning that there's an 80% chance that it's going to be cooler than the load that we're going to plan it for. We then take a look at any known bulk load additions that are coming onto the system. Like, for example, if a new Costco is planned, how much that would forecast to be added on that distribution circuit. And then we would then apply various load growth rates based on the planning engineer's knowledge of the area and historical load growth, and what we're also forecasting is kind of a base load increase as well. That results in a load forecast that we forecast on a distribution circuit, and then also reflected back onto the substation transformer. We then compare the load forecast to the distribution ratings of each equipment and conductors, the transformers, the regulators, the breakers, the conductors themselves, and then we conduct a power flow study on the distribution circuit using a commercially available tool called SIMDIST, or SIMTCC for the protection. And then we compare the loads against the rating parameters, and we identify any planning criteria violations. At that point, the planning engineer then will take a look at possible solutions to that problem, which may be simple as a load transfer or installing additional capacity, but they need to analyze at least the two options that they would consider implementing, and then present why the chosen solution is the best solution. Consideration of reliability is a big choice in that as well, and the consideration of risk and how to mitigate that risk as well. In addition, as Kevin mentioned, looking at service for new customers, as new customers come in, the preferred circuit to serve them at, the proper voltage, considerations of potential impact around other customers depending on the type of load going in there. So all those type of things get considered in coming up with the best solution on providing power to new customers and serving new growth. And also, as Kevin mentioned, with the deployment of distributed energy resources, initially there's not a big impact as DER in small quantities gets spread on the system, but as they begin to become clustered, in one segment or one node of a circuit, then we're working with our utility partners and through EPRI and conducting what's called hosting capacity analysis on those sections of those distribution circuits. And hosting capacity is basically described as the amount of distributed energy resources that can be accommodated on a circuit or section of the circuit without the need of substantial infrastructure upgrades. So you have to take a look at not just the peak loads anymore, but now you need to take a look at minimum loads. And if you have that distributed energy resources, how that could impact rising voltage across that circuit, and what you can do to mitigate that as well. And also, like we mentioned before, the impact on protection as well. We want to make sure that if you have a fault on the circuit, that the proper device operates quickly to then sectionalize and isolate that area to prevent, wider spread outages to other customers. Also, another consideration with that is single-phase versus three-phase tripping. In the impact of having that distributed energy resources may cause voltage rises on the unfaulted phases. So we need to take a look at our protection coordination and philosophy on how we analyze those types of situations. So we recognize that the planning function becomes more complex because its distributed energy resources are really variable and intermittent. So now, instead of looking at a deterministic model and looking just at peak loads, now you have to look at multiple scenarios and different time variance analysis to consider the risk that amount of distributed energy resources on the system when you think it is, and also the amount that you think you're going to get back too, which can become a more of a probabilistic function in distribution planning. So,
Thanks, Don Lee.
Yes, so we use very consistent practices and approaches to distribution planning at Duke, as there's really are best practices in the industry and industry standards. We do macro level load forecasting that look at economic indicators and trends that we're seeing in either the economy or in technology and efficiency, like improvements in HVAC technology, lighting technology, new building standards, and apply those really at a macro level, but most of our infrastructure plans are really made at a very local level. And as the other utilities have outlined, the way we've done planning in the past, our emphasis has really been on capacity to serve the peak. Our local engineers and planning experts work with communities. They understand the historical trends for the assets, the circuits, and the infrastructure. They work with developers, and they forecast the geographic needs. They use the standard systems like SIME to conduct our analysis and consider the ampacity that's necessary. We certainly want to meet all the voltage and frequency requirements, managing power factors so that we've got an efficient system. And ultimately, we want to utilize what we have to the benefit of our customers. And then when we see that our existing infrastructure is not adequate, that's when we trigger upgrades as needed. Likewise, on the transmission system, we pass information from distribution to transmission so that we can see what's happening on the major transmission nodes. Our point of interface is primarily at the transmission to distribution substation, and loads are generally aggregated there, and the net effect is run through our distribution planning and forecasting models that look more at a networked power flow as compared to the radial power flow that happens on the distribution system. And then as our planning criteria warrants, we'll conduct those upgrades as needed. But the future planning process is changing, and we've got to adapt to the needs of the future and even be much more focused on broader benefits to customers than just the capacity to serve load. Safe, reliable, and affordable energy is part of our customers' expectations, and so much today is dependent on continuous and reliable power. We've got a digital and technology-based economy. Consumers need more and more information. And technology and consumer-driven changes means that we have different demands on the electric system beyond just supplying peak capacity. Businesses increasingly demand reliable energy, and with continued growth of distributed energy and resources such as solar, the grid is being tested like never before. Our distribution system planning process takes into consideration the traditional needs such as growth, but now we're taking the opportunity to really think the broader set of investments to make sure that we're delivering a system that's comprehensively reliable, serving the customer's needs, and really meeting the North Star objectives that I mentioned in our opening statements. And the way we're approaching this is through a portfolio of innovative investments that are capabilities focused. So capabilities might be to provide our customers more information, to be more effective with their energy management in a way that's complementary to how we manage our energy system. Providing a more hardened system that's less likely to service disruptions, momentary or permanent outages and interruptions, providing more automatic restoration capability, integrating multiple forms of distributed energy resources like solar, storage, demand response systems, and energy management capabilities, and then accommodating multi-directional power flow on our distribution system more like a network, similar to the way the transmission system is designed and operated today. And we have investments organized in multiple categories. We have 7 really focused on providing these capabilities. So AMI is an investment that we already have in service in Ohio, and we're offering customers a lot of usage information that helps them manage their energy experience. Building a self-optimized grid involves installing more capacity on our circuits. The capacity will provide not just reliability benefits and enable restoration to occur in an automated fashion, but will also allow us to reconfigure our system to better accommodate the variables that we see just beyond peak load. In fact, in some cases, minimum load or intermittent load and supply differences on our system. It also provides connectivity between our circuits and the automation that allows us to make our system adaptive and flexible with very little human intervention. We have a number of investments focused on improving the hardening and the resiliency, reducing those outages and interruptions on our system. Most of them are focused on the leading causes of equipment-related failures. A program that we've also launched now under our hardening and resiliency objectives is to do targeted overhead to underground conversions for those segments of line that are outliers in terms of their performance. The faults that we see and experience in certain segments considerably exceeds that for the average customer, and we will go in and proactively convert those from overhead to underground, reducing frequent outages and interruptions, reducing the costs that are associated with having to go, in many cases, in repeat instances in a year to those same segments of line. And it doesn't just benefit the customers that are directly served from those. All the customers that are served upstream and certainly downstream from those segments will benefit. We have a series of transmission investments focused on not just physical and cybersecurity, but also more sensors and information about our asset health, and then proactive response to that information as we get better information through analytics and asset management capabilities to replace and upgrade aging equipment. And then behind the scenes of these investments, we have a series of communications network upgrades, might be fiber, certainly grid edge and wireless technologies, so that we're seeing this information in real time and certainly moving it in a way that is fast and secure. And complementing that, the advanced systems that not only control and manage and automate our system, but also take the data from sensors and more points of information and turn those into constructive and, in many cases, proactive actions that we can leverage on benefits of our customers. So that planning methodology that's worked for us in the past has been fine, but we've got to adapt with it for the future. Thanks.
Thanks, Lee. From an AEP perspective, AEP Ohio perspective here, I think we're fundamentally aligned with what you've heard the others say. I want to maybe highlight a couple points. One is, if you look at the econometrics and you look at the economists, what they say, our growth is going to be in our territories, et cetera, you'll see flat growth just about everywhere. A little bit of growth, uptick in industrial load, some uptick in commercial side, and flat, if not somewhat declining load in the customers, in the residential customer side of the business. But that doesn't really indicate where you have pockets of strong load growth. You may have 0 or 1 or 1.5% growth collectively across your system at an aggregate level, but you may have pockets of 8 or 10 or 12% growth in certain areas. They're hot areas. They're the new open areas for commercial customers to come into and residential customers that build homes. So you do have a pretty active planning environment, even though you have on the surface 0.5% load growth across your territory. So you've really got to balance those two things out. If you're thinking that the infrastructure requirements for a 0.5% load growth are real small, you have to look at really down into the details of the distribution grid to see where pockets of growth are occurring that do drive significant investment for capacity purposes. The other point I'll make is that from a planning standpoint, we all look out 8 or 10 years in our long-term planning forecast. We look at our load forecast going out that far, and we do bring in all the different sources of information to make that forecast work. But we're really focused on the distribution side, tying it to the lead time of major equipment, et cetera, to 2 to 5 years. You really, it's hard to plan more than 5 years out effectively because conditions do change significantly on the distribution grid. And I think you'll see that in the future more of that will happen as more resources come available to us. So the planning horizon traditionally for distribution is in 2 to 5 year range. I just will comment, a lot of my colleagues alluded to system protection and isolating devices and all those things. I think it's imperative to note that one of the key roles of the distribution planning engineer in the distribution business is public and employee safety, and making sure that our system can coexist in the environment with our customers and that we provide a safe environment for those customers. So understanding how the system works providing the right protective services for that system, understanding how third party, how DERs may impact that protection, I think is really critical. Because that's no one, it seems like no one else has that as their main goal, but it is our main goal, is make sure the public is protected from these things that are operating. Public is protected from our lines that fall to the ground. The public is protected from that. And then likewise, we translate that, the next step is to our employees rather. Our employees work on these lines day in, day out. They work in the worst kind of conditions. They work at night, they work in the day, they work on holidays. And it's really important that we provide the protection for our employees. We understand how our system reacts and how we isolate that system, but also understand how maybe distributed energy resources might react, and make sure that we can protect our employees against those things coming on the line in a way that could cause harm. So that's just kind of an additive to what I think you've heard from the rest of the panel on the kind of the current role, if you will, of distribution planning. The next sub-question on that is just maybe a brief comment from the panel on how would we describe a solid distribution platform, if you will. So we talk about this infrastructure platform, a platform that's an enabling platform for the future. But what are the attributes of that solid platform? And I'll just throw a couple out there, and I'll ask my colleagues to add on to that. And I would say a platform, a structure or a system that's both physically and electrically strong. So our circuits, our equipment, our poles, our lines, and everything we build needs to not only be physically strong, and that means that it must be resilient and resist outages from what you would expect to see on that grid, but also electrically strong. And by electrically strong, I mean it provides the voltage stability that our customers demand and require to operate their equipment safely and efficiently. It has to make sure that we have the capacity to meet the demands as they change both throughout the day and throughout the seasons. And they just we have to always be there for them when they need us to be there. So I think that's three attributes of what I would call a solid distribution infrastructure. I'll ask others to pile on to that. So maybe Kevin?
Yeah, we certainly would go right along with Tom's comments on both physically and electrically strong. This distribution infrastructure is going to have to be able to support any kind of application, whether it's distributed energy resources being connected to it of any size, shape. A lot of the electrification that's anticipated, such as electric vehicle charging, and any other use, which is going to translate into the distribution system being used in a multi-directional, multi-state, multi-use type of system, which is significantly different than it's been used in the past. Additionally, we've got to make sure that it's both reliable and resilient, that as we see those dynamic loads on the system, and we can support those resources that may change weekly, daily, hourly, and by minute. We've got to make sure that we're ready to serve the load at both the substation and the feeder level, and with all of those loads active or with all of those loads offline and anything in between. Thank you.
Lee, anything else to add?
Well, so I would just agree, with the points that are made. I might add the point of security. So our grid has got to be secure, both physically secure and secure from malicious threats on the cyber front. And I think another way I would spin the way we talk about having a physically and electrically hard grid is an adaptive and flexible grid. I think as we really think about the needs of the grid of the future, we're going to see the environment changes, and that environment might be driven by our customers, by technology, even by external forces that are outside of our control. And so building more adaptivity and flexibility into the grid is critical.
Good, thanks. Tom?
Yeah, you guys made a bunch of really good points about the integrity of the structures and then the operations in terms of putting up large wire and replacing the infrastructure to support the smart grid. At CEI, for example, we have a smart grid pilot that's occurring, which consists of, we've built in a number of circuit ties, we've installed advanced reclosers and expanded our SCADA network in those areas, along with AMI as well. And those customers are seeing real benefits today in terms of improvement in reliability and reduction in sustained outages, and also in reduction in outage duration as well. So that's another key component to the grid modernization plan.
Good. Thanks. So we've talked a fair amount about the kind of current structure that we have and how we do distribution planning today. We did bleed a little bit into the future. I want to bleed specifically into taking a look at how distribution planning is impacted by distributed energy resources, and talk about batteries, solar, both rooftop perhaps and community solar, if you will, microgrids, those other kinds of sources that are out there, and things that we'll have to deal with in the future, and ask each of us to talk about a little bit about, how do you see our planning function change, what impacts does it make, and what are some of the things that we have to be particularly aware of as we go forward in that space. So Tom, I'll start with you.
Sure. I covered some of these challenges and issues about a distribution planning, but I can elaborate a little bit more about integration of distributed energy resources, and including items such as energy storage. The distribution systems has been designed primarily as a radial system, which operates very well for power flow in one direction. But now you're starting to introduce, increasing levels of power flow in multiple directions. So we need to take a look at, seriously consider the impact on that. Each of our interconnection, it goes through a screening process, which the planning engineers take a look at, the size of the interconnection, the size of the generation, the type it is, where it's located, how much is there, and the ability of our system to then accommodate it. Initially there's not a big issue. However, as they begin to get clustered or more and more come on, then the planning engineer needs to kind of step back and take a look at it from the impact from the entire system as well. We also foresee a time where we could start adding potential deployment of distributed energy resources, especially in terms of storage, as a toolbox, as a potential solution for solving a capacity problem, or shifting a load, or regulating the voltage, or providing additional backup or resiliency. Currently, the cost of storage is expensive compared to more traditional solutions, but as those price of energy storage begins to drop, then that'll become a potential solution, as almost like a capacitor bank in that case, that a planning engineer can then deploy to the benefits of the distribution system. We're also monitoring changes in industry standards around smart inverters, in particular the latest standards on IEEE 1547, which is what our interconnection process is based on, and potential benefits of smart inverters, and how that could also regulate the voltage and allow more distributed energy resources, or improve hosting capacity of circuits, and be able to provide the necessary VAR support when the system does require it. So that's something that FirstEnergy is closely monitoring, working with EPRI and participating on IEEE working groups on implementing those type of technologies as well. We also see a potential benefit for the transmission system. Some of the other panelists have talked about close coordination of distribution and transmission planning, which becomes even more essential in the smart grid world, and where distributed energy resources may become valuable to the transmission system if there's a transmission outage or a contingency where a loss of supply will then cause potential voltage stability problems across the transmission system, where having those resources online could then help stabilize the system and even provide some frequency response as the load tries to get in balance with generation. At the same time, there may also be some concerns with some participation in wholesale, in some cases where some third party or customers may be participating in a wholesale market, where they can then receive signals to then operate on a system, and how we can closely coordinate that with distribution operations to ensure that the system is kept safe and reliable, and that there may be conditions on the distribution system, such as operational switching or clearance controls, or during outage restoration, where it may not be configured to adequately handle that amount of distribution generation at the time it wants to come in. So those types of relationships become more complicated and have to be carefully controlled and managed in order to continue to ensure we have a safe and reliable distribution system.
Good, thanks, Tom. Real quick, Tom, could you comment just very briefly on what kind of numbers of DERs are you seeing on your system in Ohio? Would you say it's significant, insignificant? Just a quick comment on what you see out there today.
Across Ohio, it's currently low. It's around 0.1% of our customers. However, the numbers are growing, and it's something that we track and monitor on a regular basis.
Okay, great. Lee, you want to go next and also answer that question as well as what kind of penetration you're seeing
Certainly.
in DERs?
Yeah. So Tom really stated things very well. You know, we do really see a lot of potential with distributed supply side and demand side resources, even beyond solar, batteries, and microgrids. Things like electric vehicles, home energy management systems, and other smart appliances can all be integrated into the distribution system of the future to be constructive resources. Some of them may be predictable or be able to inform our distribution planning and operations processes. Some of them may even be able to be dispatched by our system and then counted on as a resource into our planning. So there's a lot of promise here, and we really expect these technologies to advance both in their maturity and their operational reliability as well as in their cost effectiveness. And so they will become alternatives to traditional wires-based investments as we think about enhancing reliability and the other needs of the grid. Today in Ohio, Duke Energy has just under 20 megawatts of distributed resources. That's primarily solar. And we expect that number to grow by about 5 times over the next 10 years. So it's relatively small at the aggregate level. Our system peak is somewhere around 5,700 megawatts for Ohio and a small part of Kentucky. So it's not a big macro driver for the system, but I can tell you on a local level, it can certainly create challenges with managing voltage and voltage stability, frequency, and the power quality that our customers experience.
Good. Thanks, Lee. Kevin?
Yeah, I certainly would echo the comments made by the other three of my colleagues here, but I would go on to say that as we see the grid evolve through those second and third building blocks, it's really going to be imperative that the distribution utility really take on the role of being the custodian of the distribution system. The biggest change overall over time is going to be the complexity in which we have to plan for and operate the distribution level system, given the number of resources and sources of both use and generation that could be added to various points on the distribution system. As I mentioned earlier, the complexities are everything from will those resources be available online? Will all of them be available online? When might all of them not be available? And the whole spectrum in between. So that's going to require very complex modeling, forecasting, looking at voltage levels, reactive power, frequency, and will really require a complex set of tools and processes so that we can evaluate those multiple scenarios and act on those and make sure that the distribution system is configured in such a way as to balance that reliability and resiliency. In terms of penetration on our system, right now on a system load basis, our penetration is less than 0.3%. We're seeing a limited but growing number of interconnection applications for behind the meter solar, and we've seen some smaller generation applications at the distribution feeder level, such as some landfill applications.
Yeah, thank you. I'll just close up that question with a couple of observations from AEP Ohio's viewpoint. We have just under about 100 megawatts of what we call distributed energy resources on the distribution system in Ohio, mostly in net metered solar, some utility scale solar, small amount of that, and then some non-solar generation. There's a few windmills out there that are connected to the distribution grid, and a couple prime movers that also contribute to that. As far as the connection of DERs to the system, I'll just add, we're looking very closely at the opportunity to apply distributed resources, specifically batteries, to our distribution grid for the purposes of really taking advantage of an opportunity to, if you will, pancake value to several stakeholders. So you can look at a storage device, and at today's prices, a storage device strictly for the purposes of backing up a load, particularly a residential load, is very costly, and it just doesn't pencil out. But if you're able to pancake a storage device that provides the capacity that's needed to maybe cover a capacity shortfall in a growing area, and then you add to that perhaps the opportunity to engage our customers in participating and using that device at the time of an outage, and maybe provide some ride-through for them for 6-8 hours ride-through. If you provide 6 hours of ride-through, you ride through a high 90s% of all the outages that occur in a residential customer. And you turn around and also use that battery perhaps to provide support to the transmission grid, fast frequency response, or other ancillary services. You can suddenly take what is a high-cost resource like a distribution battery and turn it into a benefit for two or three different entities, and you pancake those values together, and you can actually get a battery, even at today's prices, that pencils out. It might be a service you offer to your customers at a small fee and a tariff rate to give them the resiliency they want, coupled with the benefit to the distribution grid for providing capacity resource and voltage stabilization on the distribution side. And then finally, you might be able to put it in a market and do something with the market. So those are some of the things we're thinking about with DER, is to use them creatively to benefit not only our customers, which is first and foremost, but then to benefit the grid behind it, and finally maybe to provide an ancillary service to a third party. So, so that's something else that we're doing in the distribution side relative to DERs. I want to move to a question about risk, and I think it was alluded to by a couple of the others, and talk about, as if you foresee a future with significant penetration of different types of resources on the distribution grid. We now have this grid that is having bidirectional power flows, and it's complex in how it operates. It may be a part of a market scenario, et cetera. What are the risks that you see to our customers in particular from a grid, that grid of the future that has that kind of penetration? So I'll start with Kevin here.
Yeah, so I think the biggest thing in terms of risk is really around safety. Safety of the system, safety and protection of our customers and our employees, is Tom, you mentioned earlier. Really making sure that as distributed energy resources are added to the grid, that they're done in a fashion that the distribution utility can work in a cooperative fashion with those parties that are adding those resources to the grid, such that they're added in a way that the distribution system will operate reliably, but also that both that equipment being added as well as the equipment already on the distribution system is well protected. And like we mentioned earlier, we've got to make sure that we're constantly keeping the safety of both the public and our employees first and foremost.
Thanks, Kevin. Tom, anything to add?
Yeah, I would agree, strongly about the safety aspects of it, the ability to implement like anti-islanding protection, but it's also very important too for the system operators to be able to have visibility on what's occurring on the distribution grid in terms of the amount and the location of the distributed energy resources and how much that is feeding back onto the system and what the potential impact is. And also to be able to plan and operate, not just from a planning perspective, but from a real-time basis, when those resources are online and also when those resources are not online as well, to ensure that there's enough capacity to then continue to, safely and reliably operate the distribution system.
Good. Lee?
Yeah, so it's well stated by Kevin and Tom. I think, safety and certainly reliability effects of the resources, if they're not integrated in a way that they're constructive parts of the system, certainly could be a risk. The other thing is if those resources are competing against other functionality. So for instance, sometimes we manage voltage and efficiency programs through the way we manage voltage and reactive power. You have a distributed energy resource that is contributing to higher voltage on the grid, and now you've got two competing forces. So there are complications with getting these resources out, and as their scale increases, that's where the complications become much more challenging for the utility, both from a planning and an operating standpoint.
I don't think there's any question that those are the challenges that as you get penetration levels that increase in the system, that those really become front and center, is managing the system character, if you will, to make sure that system doesn't respond in a way that can be negative to our customers from a reliability, even from a safety standpoint. Delivering high voltage to our customers can cause significant safety issues and equipment damage as well. I want to move to really kind of looking forward. It's our question number 7, but what are the key capabilities that we're going to need to prioritize over the next decade, if you will, to ensure that our customers here in Ohio continue to receive this reliable and resilient electric service, but at the same time making sure that we can advance the opportunity for our customers to use alternative energy sources, advance the opportunity for our customers to experience and if, maybe going back to this morning's first session, to give them the things that they really want. Like they said, they don't want kilowatt hours, they want comfort, they want cool things, they want warm things, they want these things that electricity delivers. So I want to talk next about what we think these key capabilities are going into the future. So Lee, I'll start with you.
Okay. Yeah, so we've already discussed reliability, and I think that's just the foundation. But beyond reliability, there are a number of capabilities that are essential to giving our customers this unique and distinguished value proposition. I'll start with kind of the smart aspects of the system that are connected to the systems, the IT and technology, as well as the sensors and the devices out there. So behind the scenes, being able to effectively manage distributed energy resources with systems like DER management systems, effective outage management and distribution management systems are key and centered there. Being able to manage the data that we are getting from more sensors and more online monitoring, smarter devices out there, analyze that data and turn that data into something valuable, either in how we manage our assets or how our customers experience their energy interactions. Behind those scenes, customer information and meter data management are other systems and enablers there. And the network of communications that is really grounded underneath that is essential. So we've got more automated devices, we'll have more sensors, more equipment that is producing information. Much of that equipment actually comes with communications equipment built in. And having fast and reliable communications that is secure, not just for planning purposes, but from an operation standpoint, from the control room through our substations and even to the edge of the grid, will become very essential. And this will involve really a complex network of some secure and privately owned fiber. There'll certainly be some privately owned wireless and then some public wireless technologies that will really work together to provide multiple platforms depending on the latency requirements, the security requirements, and the operational needs of the system. I'll just stop there, Tom.
Thanks, Lee. Tom,
Okay.
add to that?
Just a couple things. I think first of all, it's very important as we get into the smart grid world to not forget about doing the basics. And the importance, again, about the solid distribution infrastructure, but the basics around the execution of our inspection and maintenance practices, the circuit inspections, pole inspections, vegetation management practices that can really bite us if we don't, take care of those things as we deploy smart grid and ensure that our customers continue to receive the excellent reliability that they are currently also receiving at this time. And also, Lee mentioned the importance of data. As we deploy more devices in the field like sensors, there's going to be a whole proliferation of data that's going to be available to planning engineers and system operators in how we manage that data to then make sure that we pay attention to the ones that are really meaningful, and then to not get bogged down by the ones that can then, result in delays in processes or delays in making decisions that impact the system. So combination of sensors on the system that provide a lot of telemetry and the operations of the system and the health of our assets can help us make better decisions in managing our assets and predictive on when equipment could potentially fail, and then take the steps forward to then replace it before it becomes an issue. And then all the data that becomes available through AMI and how our customers use power and how we could also implement that type of data into our planning and operating process.
Good. Thanks, Tom. Kevin?
Yeah, so we're really looking for the future to make sure we've got systems, data, and processes and capabilities in place to make sure we can analyze that multi-directional use of the distribution system. This is going to include making sure we've got an overall end-to-end model of our distribution system that connects every single source and every single load on our system, make sure we can identify every meter and to the extent possible, even identify all those sources that are there behind the meter. We're also going to need to make sure that for the future we've got the proper equipment and facilities out in the field that has the intelligence to sense, analyze, and respond to problems, as well as to make sure those resources can stay online.
I'll just kind of wrap that topic up by recognizing, Tom's statement about the blocking and tackling. We have to do the blocking and tackling, the basic function of running a distribution grid and doing that well. If we don't do that well, it really doesn't give us the opportunity to expand beyond that and go beyond. You did hear also the priority on systems, whether it be meter data management systems behind all that myriad of meter data that we'll be getting, whether it be DERMS, a distributed energy resource management system that'll be necessary for all of us to have, that many of us don't. I know here we at AEP do not have a DERMS system in place. We are evaluating that as we move forward. We have to have a robust outage management system to go along with that as well. Communications will be critical. 10 years ago, we didn't have anything beyond the substation communicating back information from what's on a distribution grid, and today and into the future will be thousands and thousands of points of that. AMI meters are just one source of such information that becomes valuable to the planning engineer as they look at the performance of the grid and then try to predict the needs going forward. You're going to have sensors in every single piece of equipment that's attached. You're going to have sensors in people's homes that can provide valuable information to the system from a planning perspective. And I'll just close this topic with, we can't ignore the cyber elements associated with this. We've seen, overseas what happens when someone can take control of your grid through SCADA systems, et cetera. And we're going to have addressable devices that proliferate across our distribution grid, and we have to make sure we get the cyber right. We can't allow folks to intrude upon our systems and impact our customers in the way that could be possible if we're not wary enough and diligent enough to make sure cyber is taken care of all the time for every piece of equipment. Every single thing that's addressable needs to have a cyber clearance on it. It has to be robust. So we have to get that done. I want to close and make sure I give the commissioners time to ask us questions. I'll ask one final question to the panel, and then we'll close for that day. So the last question is, how should customers and third-party stakeholders participate in the distribution planning process? So what we've talked about is pretty internal right now. We've talked about our planning engineers and how we go about the planning function, how we collect data and information, but I want to kind of open it up and say, is there a role for our customers and other third-party stakeholders to participate in that distribution planning process? I'll start with Kevin.
Yeah, we believe going forward, there's really going to be two methods or ways that all stakeholders can really participate with us in the distribution planning process. The first way is really going to probably be through a collaborative process that will provide all those stakeholders opportunities to provide ideas and feedback. There will also be formal processes that will change and evolve as the market transforms. But in today's world, interconnection applications are an example of more of the formal processes that that stakeholders will be required to follow.
Good. Lee?
Yeah, so we really believe that the electric distribution utilities, we're responsible for the safety, the reliability, the resilience of the system, and we're uniquely positioned and qualified to execute that short and long-term planning. But we also believe that new distributed resources and new programs like energy efficiency and demand response will play a role in that grid of the future. And they've got to be enabled through our investments, through our technology, so that we can use all of those resources in our processes to safely meet those reliability, resiliency, and customer expectations. And it's really our role to balance that customer piece to make sure that all our customers' needs are met and to ensure that customer value is delivered.
Good, Tom?
Yeah, I would add also, and I agree with all the comments that are made so far, but distribution planning is an electrical engineering function, and it's conducted by experienced and knowledgeable utility engineers who understand their system and understand the relationships and the complexities between operations and the transmission system to really be able to safely and reliably operate the system. That may not be the same motivation may not occur with other parties in terms of ensuring safety and ensuring that you're considering reliability and the impact of all the decisions has on the system from a whole. In addition, distribution planning engineers sometimes can deal with sensitive customer load information. Some customers may be planning an expansion and they really don't want that to be made public. So the utility engineers have to exercise a certain amount of sensitivity and confidentiality in dealing with those type of situations. Thank you.
So I think the last thing I'll add to that point and put a fine point on the rest of it is I think it's clear that distribution planning is a utility function driven by the engineers who understand and know the system and have the ability and the tool sets to effectively evaluate the performance of the system both in real time and in going forward. But I think it's really critical, though, that we recognize that for us to integrate and work with other distributed energy resources that might be on the grid, that we have to develop strong partnerships. We have to develop partnerships with those providers who are in the energy efficiency space. They support us. They're effective and part of who we are. Likewise, the demand reduction and demand management systems that are out there in the third-party world. And finally, the need to make sure that we have good partners in the development of tool sets and technology that help us be successful. Partnership in the future, I think, is going to be more important than it ever has been, and we have to look outside of our own kind of world, if you will, as a distribution planning engineer, and recognize there are partners that can help us achieve the same goals that we have, which is a reliable and a resilient and a secure distribution grid. So with that, Chairman Hocko, I'll turn it back to you for questions. Thank you for your time and attention today.
Thank you. Wonderfully thorough panel, and thanks to the four of you for your presentations and your dialogue. I'd like to begin with actually staff and have them ask some questions. This is obviously a very technical space. Our staff. I'm sure understands that we do X right now, and what we're trying to figure out is as we evolve into doing, X plus, what is it that the utilities, and we got a lot of that information from you all, what is it that the utilities need to be doing? But of course, a lot of that engagement will happen at the staff level. So without further ado, Christina.
Kevin, for you specifically, you mentioned that you were partnering, or DP&L was partnering with EPRI to conduct hosting capacity analysis. Just kind of curious the scope of that analysis, and then challenges to potentially making that data available to other parties. I think we'll hear recommendations for kind of sharing that data more broadly during the later part of the day. So just any comments on that?
I believe that was Tom with FirstEnergy that mentioned that EPRI
apologies.
partnership.
Yeah, we are partnering or collaborating with EPRI, as well as a number of other utilities who are involved in the EPRI advisory committees. We're not alone in facing these challenges, and we recognize that there's a potential impact to the system as distribution energy resources come online. We're utilizing what's called an EPRI drive tool. And I believe Jeff Smith, one of the presenters later, we work closely with Jeff and EPRI on using the drive tool as an analysis function to determine potential system problems as distributed energy resources come online. Currently, we're focusing, because FirstEnergy is a large utility. We've got 10 operating companies across 5 states. And I mentioned that currently the amount of penetration is relatively low in Ohio, but it's actually increasing in New Jersey, JCP&L, to a point where we're starting to get concerned about the impacts of it. So we're looking at a couple different circuits and starting to do the hosting capacity analysis. using the EPRI drive tool in combination with a SIMDIST to then identify potential problems and then working with EPRI and others to come up with potential solutions to continue to safely operate the system.
I guess, and the second part of that is kind of how can that data be shared so that we get, the least cost kind of, external non-wireless alternatives that may exist outside of the utilities domain? And do you see kind of an engagement opportunity or do you have a vision for that yet?
We don't have a vision for that yet because, again, we're trying to solve problems that are being caused by increasing penetration of distributed energy resources on the system. So there may be different solutions in terms of like smart inverters, for example, or other voltage regulating devices that could then help. But this is primarily a utility problem that's being solved because of the proliferation of distributed energy resources on the system. It's not a load growth or capacity issue.
I think if I might add a little bit to that, one of the challenges on the distribution grid is it's a very dynamic situation, and hosting capacity is very sensitive to the character of the circuit that you're evaluating. So if today you have a certain hosting capacity on that circuit and tomorrow Costco moves in on that circuit somewhere and plops 800 kW down on top of it, suddenly your whole hosting capacity evaluation has to be redone. So some concern about posting that because it does change very dynamically and it's not in real time. I think our goal, though, AEP Ohio's goal, is to be able to turn hosting capacity evaluations around very, very quickly because of the work that EPRI's done, fine work that EPRI's done to help bring that forward to the industry and tie it in with our existing planning tools. But the systems change very dynamically. If I cut a piece of circuit off and move it to another circuit, suddenly the whole evaluation changes. So there's some challenges there of keeping it fresh and current over beyond the snapshot in time that you provide it to.
Thank you. One question for whoever would like to answer it is after we've heard this morning's panel and then your panel just now, do you see yourself in the future more like, the question I'm going to ask is, do you see yourself as a distribution system operator where you are in charge of physical cybersecurity, in charge of enabling service providers and customers to transact and interact on the grid? Or do you see yourself a little bit more than that? By that I mean, like, do you see yourself also participating in that market? So do you see yourself more like a MISO or a PJM, or a little bit more than that? And the second question, before I forget it, is have you discussed with local balancing authorities, like in this case, it used to be if you were vertically integrated, your transmission owner, but now more like PJM of MISO, which they've had lots of issues, operational complexities, having wind interject into the grid, especially in MISO more than PJM, and they've worked on solving these problems. Now, of course, yours would be on a micro scale. Thank you.
Yes, I'll be glad to start. I'll answer both questions. I'll try to be as brief as I can. But so we really want to be more than just a wires company. We want to be more than a distribution system operator. And we think that there are unique relationships that exist between us and our customers that will offer great mutual value and benefit. And so that is really a role that is much larger. We want to empower our customers with regard to their energy usage, their energy experience, and the programs that they can participate in ways that are constructive in terms of how we manage the transmission and the distribution system. And then as it relates to integrating renewables especially, so we in North Carolina, number 2 in the country with connected solar. Most of it is utility scale, and as it relates to hosting capacity, that's been a real challenge for us. I mean, we've got a backlog in our interconnection queue. We've been leveraging the technology that's been developed with EPRI and others to do some screening criteria. But at the same time, we are finding solutions. Some of those solutions are operational solutions. Some of those solutions are controls in terms of the scale and pace and the location for where we see the solar entering our system. And then we believe in the future with additional technologies, energy management systems, smart appliances, and energy storage, we can better integrate those resources, dealing both with the local issues that are tied to the infrastructure, but even more of a challenge is the bulk power system challenges that we see, especially during minimum load conditions, when we see, mild weather, sunny days, low load, and an excess supply of generation. So we certainly do learn from our other utilities in the other areas around ways to mitigate that.
Good, thank you. Kevin?
So certainly we, as I mentioned earlier, we do view ourselves as being that custodian of the distribution system, whether you call it distribution system operator or what have you. But I think we would like to have the opportunity to participate in being just more than that. How that comes about and in what form or fashion, I think, has yet to be determined, but we certainly wouldn't want to necessarily be excluded from that. Specifically, as it relates to your question about renewables, we do have some experience with solar, as well as 5 years ago, one of our affiliates with AES installed its first generation generation battery-based energy system at one of our sub-transmission locations, and participated in the PJM fast regulation market. And we learned a lot from that. We've learned a lot from both the solar and the battery storage, and we continue to do so. But we don't have much in terms of any specific experience relative to wind.
I'll add something and then look to Tom next, but I would agree with Lee that clearly we believe that AEP's role is not just to be a distribution system operator. We believe we're uniquely positioned to really leverage a number of different stakeholders' interests, both the customer's interest, the utility's interest, and the community's interest in being able to participate in the kind of the broader set of opportunities we can bring to our customers in multiple ways. And you run the risk of just being a DSO of kind of sitting back and letting the third parties do what they do and maybe sub-optimizing the system and creating some imbalances that are going to need to be need to be mitigated in another way with maybe advanced distribution investment to cover for that. So certainly be part of the discussion and part of the, if I would, as I mentioned before, the partnership that's out there, but also to participate in it as well, because I think we can bring some value by, again, pancaking, in some cases, multiple value streams together into a single product or installation that could bring this value to the customer, value to the shareholders, value to the communities, et cetera. I think you got to look at us in both ways. So we see ourselves in the future doing all that. Now the rules have to be managed, and we have to understand, what all of our roles are. And certainly, I'm not saying you have to you block out other third parties from participating. I think it has to be a highly collaborative environment in which we work, and there's room. I think there's room for a number of people to participate in that. Tom, anything?
Yeah, we would agree with everything that was stated. We feel strongly that we should be responsible to control the distribution system, and also looking for opportunities to participate in those other services that we feel that our customers can benefit from.
This is a question regarding the integration of distributed energy resources. I was wondering how, given that the impacts of these resources is so much dependent on the location of the resources, how much of your planning process is proactive and how much of your planning process is sort of reactive? Because the siting of these projects is up to the customer. So I was wondering how much of this process is proactive versus reactive?
Planning is a proactive process. It's, you're trying to anticipate the impact of load on the distribution system, and then so you could proactively identify potential problems or criteria violations, and then take the necessary steps to then implement a solution. So it's very similar as well with as distributed energy resources come online. Currently, in Ohio, it hasn't been as much of an issue, but we're starting to see it as an issue in New Jersey. So the additional tools that we're looking at, such as the hosting capacity, can then provide an additional proactive approach for our planning engineers to determine those system impacts and then be able to propose solutions before it has any kind of a problem on our system.
Yeah, I think the lead time of projects of that nature is such that we have, plenty of lead time to evaluate the impact that those projects might have to the distribution grid before they're built, even before they're sited, and recognizing that there are locations for projects of that type, distributed energy resource projects, say a solar field, et cetera, that some are better locations than others, and the impact of integrating those into the system and the requirements perhaps to upgrade your system to accept the interconnection at a place that the developer wants versus a place that's more robust for us is just it's a back and forth, and it becomes a financial negotiation, but then it also becomes a we have to have a concern about our customers and the impact of those customers from that device where it is. So, but I think it's largely proactive. We don't get behind the eight ball on these things just because of the lead time and the scale that the projects are.
Yeah, we also anticipate working with developers on siting locations too, if they do want to put together a larger installation, and where's the best location on a circuit in order to accommodate that without having to have costly upgrades, and also to ensure that it's operated safely.
And what we find is we typically find that a lot of these developers will have multiple locations in mind so that they can evaluate the cost of any type of infrastructure extensions that might come, and they can evaluate the projects based on that.
Yeah, I'll add, it's also a matter of the scale and pace of what you're seeing. So here in Ohio, it's easy to be proactive because the scale and the pace is very manageable, and we can work with the developers and certainly work with our customers to know in advance. But I'll tell you where we've seen a lot of penetration happen in a very, very short period of time, we have found that we have been very reactive. We do have a large interconnection queue, for example, in the Carolinas. Hawaii is living with this scale and pace of penetration, and our advanced distribution planning methods still have some gaps as it relates to modeling, valuing variable distributed resources, comparing them to other conventional solutions, and then providing locational cost attributes. So those are I'll say developments in the science of distribution planning that we are working with others, both other utilities, certainly the Electric Power Research Institute, and some software developers to try to close those gaps.
Yes. This is an open question. Are there any steps towards reliability that we're not taking that we should be taking? And then at the moment, the Commission requires you to report in, Katie and SEFRI as metrics for reliability. Are there other metrics that we should be looking at?
So I'll be glad to start. And I will say from a reliability standpoint, we do need to look at our broad portfolio of reliability investments. And we've had a number of reliability enhancing programs over the years that we seem to nibble away at certain reliability problems. And we need to go ahead and kind of put those problems to rest. So an example might be a transformer standard that it was the right thing to do back in the 60s and 70s, and we need to clean that up off of our system. I mentioned earlier targeted undergrounding, where we really go after those poorest performing segments of line that you see repeat outages over and over again. High cost to restore, many of them are in hard to access areas, and the customers are seeing poor satisfaction in their experience. Those are examples of where we would encourage more proactive reliability investments. And likewise, there are other indicators to consider. So as an example, we find that customer satisfaction is very directly tied to multiple interruptions. So we use IEEE standard indicator, customers experiencing multiple interruptions, SEMI, and it has a reference to the number of interruptions. So SEMI 6 would refer to customers who experience 6 or more interruptions per year, as an example. And we feel that targeting those outliers in terms of their reliability experience really does not just move the average, but it targets those poorest areas of performance. So semi might be an example. And then just looking at the total number of outages and faults that we're seeing on our system, because that translates to power quality, momentary interruptions, fault duty on our equipment, and other problem areas for the system.
Yeah, we have very similar type programs that Lee mentioned as well. We also look at tracking semi programs on customers experiencing multiple interruptions. We also look at it from a device level as well. So if we have a device out there that starts to exceed a criteria on a certain number of interruptions, we want to also go out there and investigate that as well too. And we have a number of standard reliability improvement programs that all of our operating companies look at and evaluate and track, like worst performing circuit programs, where we file reports to the commissions every year and track our worst performing circuits with a goal of improving those or having those removed from the list so they don't become repeaters. So a very similar type approach we have as well.
I think the questions are, for the most part, answered. I agree. Blocking and tackling is absolutely critical. You've got to get your tree trimming done, clean. Have a 4-year cycle or 5-year cycle, whatever you deem to be prudent. The other thing I would think we haven't talked about. We talk about resiliency, but how do you get to resiliency? One of those ways is through hardening. Really taking a look at how you build your system. And then doing perhaps some selective hardening of existing infrastructure. So at AEP Ohio, we've instituted several years ago a hardening design standard. So we've increased really the size and size of our structures. We basically moved them a little closer together to give us a hardened infrastructure against high winds, if you will, and also against tree contact with the wires, et cetera. So if we can provide, if you look at major storms, a big restoration issue, and the thing that prevents us from getting power back on as quickly as possible is pole replacements, broken poles due to structure damage. And if you can harden that system against that, and there's a great case study in Florida with Hurricane Irma, if you look at the pole damage in Florida from their hardening efforts, but they did spend $4.5 billion doing that over the years. I know Lee's close to that from Duke's standpoint down there. But hardening the system, I think, is something, you ask, what else could we be doing? We really take a look at some of our core backbone feeders and think about hardening those up so that they can be more resilient to the weather events that do occur in the territory in Ohio.
I would echo the comments of my colleagues and state that DP&L, we feel that we today meet or in some cases exceed the minimum reliability standards set by the Commission. But we have a lot of additional internal programs where we look at local reliability challenges and areas of concern and try and address those when they actually arise. I would also add that as the core distribution utility infrastructure ages, the risks of that aging infrastructure increases in terms of what we term as asset health. We're looking for opportunities to figure out ways to economically and effectively address those aging assets and ultimately prevent degradation in any type of our reliability performance, which is why we've been looking at things such as our distribution investment rider, which we've been talking with staff and the Commission about in our electric security plan and our distribution rate case.
Okay, very good. Commissioners? Larry?
Sure. We have 6 minutes, so you can answer this yes or no. So it's pretty simple. I want to follow up on Hisham's question in my own way, I guess. Each of you advocated a policy of inclusion as it relates to the utility or utilities' participation in a modernized grid and something other than a simple DSO. Let me flip it a little bit, and that is that if there is a platform, grid platform architecture evolved in the future, do any of you envision a circumstance in which a non-utility can provide a transactional platform and attach it to an EDUD system asset? Or you could not respond. That's okay too.
I guess I would, I don't know that I can answer it yes or no. I would say it certainly is possible. Certainly is possible.
Yeah, I think the future is going to be different than what it is today, and I would not rule out that possibility. But there are a number of really significant conditions that need to be evaluated along with that before I could say yes. But I think to say no, it really doesn't make sense either, so.
So we have a series of qualified yeses.
That's exactly what you have.
Okay, thank you, thank you.
Beth?
My question is sort of along those same lines in that forecasting is such an inexact science. And so I guess I'm kind of curious about what is in your forecast that you tend to find to be the most difficult? What forecast? And then what do you do when those forecasts are wrong? I can't imagine how you can get them right all the time, but maybe you can. So could you talk a little bit about that?
I'll take a first stab, I guess. Yeah, forecasting is completely inexact. I think the pieces of the forecast they're really hard. I would have suggested after 2008, 2009, and the change in the recession that we had, or whatever you want to call that politically, I would have expected the load from our residential sector to come back, and it just never came back. So I think that really threw a monkey wrench in our forecast, and we've adjusted for that. Large loads, I think, is the other thing. The economic conditions in an area change over time, and maybe if there's an incentive for something to happen, then suddenly you can see a bunch of, what we call block loads of 500 kW and above loads come onto your system and really wreak havoc with your planning, because those are big enough to cause a real-time issue right now. If you do forecast and the loads don't come true, we've got a word that we use all the time: let's defer it. So, we're at the stage where, if you're big enough, you have enough project going on that we could defer a substation a year if we didn't see the load developed. We'll take that transformer we might have ordered for it and move it to another project that we have in play where the opposite has happened, where the forecast was low and we got more load than we thought. So you're always playing, back and forth on those kinds of things, and the AEP system is large as well. We actually move transformers across, operational borders and sell transformers to each other to facilitate that as well. So I think you can recover. The lead times are long enough for the bigger projects that you can see that happening and make adjustments along the way.
I would agree with Tom's perspectives on that. With the downturn in 2008, we saw significant a loss of load on our system in aggregate, and did we see it come back the way we expected it to? No, and so we've had to adjust our thinking, as well as we've started to see the impacts of a lot of the energy efficiency things that are really grabbing hold, like LED lighting. That is really making shifts in terms of keeping that load flat, if almost no growth. But we do see, I think where kind of the big misses come into play for us is really at the localized levels on specific feeders or at substations where, say, for example, a manufacturer may have added a line to their process and we weren't aware of it. All of a sudden we have a distribution circuit that is now overloaded, and we're having to scramble and be very reactive in terms of how we address those circumstances.
At FirstEnergy, our distribution planning function is distributed so that we have planning engineers who are really located out in the field. And so they have a pretty good pulse on what's going on within that local area. So there's a lot of discussions with like the customer support representatives and the area managers to be able to get a good heads up when load does begin to appear too. And I mentioned earlier about our 80-20 load forecasting, but we also have to take a look at, in consideration, if it ends up being a much hotter summer than that, maybe a 1 in 10 summer or a 1 in 50 summer, and then what sort of short-term steps we can take to maybe ensure that our assets don't become overheated and remain in service. So that's also included within the planning process.
Yeah, so I'll be a little redundant, but we see it's different depending on the density of customer and customer base. So generally where we have most of our growth, we do have a network area and a lot of interconnections between our facilities. And so we maintain a small margin in terms of the capacity that we have in not just the individual circuits, but in the geographic areas that give us a little bit of flexibility, but it's very rare that we miss that forecast. And then we also have operating procedures that we could fall back on, in the event that we had a peak that occurred in a day that, we had to either do demand response or rotate interruptions. It's very rare. In fact, it's almost never that occurs. But generally, by having margin built into our system, having that flexibility and adaptability so that we can serve loads from multiple directions and sources is really the best way to mitigate errors in our forecasting.
Okay, I don't know that I have questions, but more so, this was a very informative panel. Thank you very much. I'm trying to get to some of the sort of pivotal commission questions that we'll have to ask as we push towards the a policy piece that we'll put out. And so, look. And these can be head nods or yeses or nos or however you'd like to answer it. So there's a certain level of distribution system planning that goes on today that has happened historically. The PUCO has some role in that, evaluating the reasonableness of that forecasting. And so, but that is generally speaking, I mean, that is the distribution utility engineering and capability sort of bailiwick, right? I mean, you guys are the electrical engineers, you know your systems, you're conducting these analyses. And the reason why we're talking about this potential what's next is because an increased proliferation potentially of distributed resources and just a two-way data flow. We don't know what's coming next, but we know that this technology is proliferating just broadly, and so we want to make ourselves ready. And so we're talking about then some additional distribution planning functions. I mean, hosting capacity, is that something that's not something that you've done in the past, right? Or but okay, but is the scope changing with a increased proliferation of DERs, or is it still the same old hosting capacity analysis that you've always done?
No, I think for us, we're using modern tools recently developed by EPRI in concert with, the utility industry to look at hosting capacity in a very, very transparent way, make sure that we can enumerate and talk about the things that a DER added to a distribution system can do to it and be reflective of that. So we can do hosting capacity. I think most of us have systems in place that do hosting capacity on a regular basis. So we see that obviously increasing in the future. It depends upon the penetration. I will say the penetration, when you look at the market right now in AEP's territory, for example, across our 11 states, we get roughly 25 requests a month, 25 per month for interconnection to a distributed energy resource. You compare that to what's happening in California, just to put it in perspective, they get 25,000 a month, the utilities out there. So
Yeah.
we cover 5.5 million customers in 11 states, and we get 25 per month. It's just not quote unquote real yet for us, but it's coming. I don't think there's any question it's coming as prices
enough.
come down, as the value of the DER rises. We have to be prepared for that, and I think we're building tool sets to help us do that.
Okay, very good. And that also is the case for modeling load forecasts. You know this stuff is coming, and so you are creating tools to evaluate this future.
Yeah, it's more complex. I don't think anyone will argue with you. It's much more complex. What is, you have to know the value of all the loads on your system and all the sources on your system in real time. You used to only have one source, and it started at the substation. Now it's everywhere. So it's more complex, but I believe the tool sets are evolving. I think you're going to hear about that from the EPRI speaker later.
Okay.
Talk about those tool sets. They are evolving, and they're becoming more mature, and the best part about it is they're linking and integrating in with tool sets we already use and know very, very well. So.
Okay, so then one level of question then is for the commission to answer is, do we at all try and increase sort of is it continue to be the same standard that exists today for when you submit forecasts? Is it the same level of operation from a staff perspective? Or are we doing any kind of deeper dive analysis based upon this changing world? I think that's sort of one level of inquiry, and it's not something that we necessarily have to tackle now or today. The other is as your analyses changes, and if you need additional or different technologies in order to conduct that analysis, obviously as the regulator, there may potentially be applications, investments, recovery, et cetera, associated with that. So that's another level of analysis. And then the third level of analysis that I didn't know that we were really going to get to, but because I guess I didn't really foresee it, is this whole is the marketplace discussion again, and the non-wires alternatives, and who gets to participate in that space, and how do we create the right environment, if we're again thinking of the first panel, tying it back to customers, that allows for true customer betterment. So comments on that? I think those are kind of like the three levels of inquiry that I'm taking out of this, which is, what is the scope of the staff of the agency and the commission scope as your tools advance, your systems advance, your tests, your forecasts, they advance, and then, of course, the dollars level, and then lastly, the marketplace level. Any other considerations that we should be thinking about?
Yeah, I think from a load forecasting perspective, really or just a forecasting perspective in general, I think the question that's going to, or the area that's really going to be challenging for all of us is what is that penetration? What is that growth going to be on a forward-looking basis? We certainly know what historically it is. We get a certain number of applications on an annual basis. Probably a lot less than AEP gets, but we do get applications on an annual basis, but it's going to be very hard to forecast how those might grow. As technology evolves and the price points for those distributed energy resources come down, obviously that might drive more. But being able to forecast that's going to be very challenging. And I do think that we're going, as an industry, we're going to have to keep our tools in tip-top shape. And that will require certainly ongoing investments to make sure that our tools and our skill sets are up to par and can handle that.
I would just like to point out that from my perspective, I can't speak for everyone, I expect you to do that. And I don't expect you to wait for some other process to occur before you do it.
Agreed.
Okay?
Yeah, fully agree.
Yeah, I think we all agree with that.
Certainly do.
I think there's going to be pressure on both the planning engineering staff, as these things proliferate. It's people and processes. So the IT systems, the DERM system that I think all of us will ultimately have to build and put in place is a capital investment that we'll have to make on the IT kind of system side. And on the people side, it's our planning engineers and it's our distribution system operators who've been operating a radial one-way feed system for their entire career, and now we're going to turn it into a multi-directional, multi-source distribution grid. To me, I think that the key element there is data analytics, and predictive analysis is going to be key to that. We cannot ask a distribution system operator to figure out what's happening on a circuit that has 12 different distributed energy resources on it, all operating differently depending upon what's happening. We've got to have analytics behind us and predictive analysis and machine learning tools, et cetera, to help us do that. To me, that's a critical piece as well. I think the others.
Yeah, well, I'll just, reinforce, we're responsible and we're accountable for the outcomes on our system. Yeah. And that means not just designing for capacity to meet peak like we have in the past, but really to build this system that's flexible and adaptable to the scenarios that we've been talking about, whether it's more distributed resources, more customer engagement in programs, even more tests to our system from weather and other reliability and security threats. I mean, it's incumbent upon us. We're changing our standards. We're making prudent investments to do that. Certainly, you want to encourage those investments so that we stay ahead of the threats and the challenges, but also so that we create the value for the customer, whether it's in systems, communications infrastructure, hardening our system, providing more redundancy and capacity. That's incumbent upon us, and you need to encourage that in your role with policy and regulation going forward.
Okay, very good. Round of applause for our panelists. Thank you. Okay, so it is 1:10 right now. I think it's probably a tall order to have people have lunch and be back here in 45. Or can we do that? Sure. Okay, why not? 2 o'clock. We'll start at 2 o'clock. Thank you.